Hey everybody, welcome to lesson number 1 of Unit 6, which is Analytic Trigonometry. The lesson is the fundamental trig identities. Alright, so just real quick heads up, I have these formulas that we're going to need. They're not formulas, they're identities that we're going to need. You can either copy them down right now, pause the video to do that, or if you can get to the website, you can print out the helpful trig formulas worksheet. They're written at the bottom. So go ahead and do that now. Alright, so identities are sometimes pretty difficult. So it's not going to be something that you can watch this video and be like, oh, okay, I get how to do identities now. You really have to kind of practice, and you want to keep these identities that I've written down for you handy when you first start doing these, because it's kind of tough thing to get used to. And you're going to see when we start doing some identities exactly what I mean. Right. First though, we're going to look at some problems that are going to be using some of the identities, such as the reciprocal identities. And this is a problem that kind of works with those. Okay, they give us cosine of some angle is equal to -3/7, and they're telling us tan is greater than 0. They want to find all 6 trig functions. Alright, well, first of all, out of the 6, we already have cosine, which is good. And they tell us something about tan. Now, the reason is because we need to figure out what sine should be, and depending on what these two happen to be, it'll define what sine's sine has to be. What do I mean by that? Well, cosine here is negative, and tangent here is greater than 0, so it has to be positive. And the only place in a coordinate plane that happens is in quadrant 3. Right? We have cosine negative, tan positive. Now that we know what quadrant we're in, we also can figure out what sine's sine has to be. And seeing as sine is the x-coordinate, we're in the negatives this way, so sine is going to also have to be negative. Okay, that's important, because we want to make sure we have the correct sign. Right? So we're going to start off using the Pythagorean identities, and that's going to help us figure out sine. Alright, so here's what we're going to do. We're going to use sine squared plus cosine squared equal to 1. Pythagorean identity. Okay. The reason why we're using that is because we have something for cosine that we can sub in. So our next step, we have sine squared plus -3/7 squared equal to 1. We're going to square all that. It's 9/49. Okay, and then we want to start solving for sine. So we have to subtract that 9/49 from both sides. I'm going to change that 1 into 49/49 for my subtraction. And now we've got only one thing left to deal with, and that's that square, which we're going to just take the root of both sides. So we have square root of 40, which I'm just going to leave alone. I don't really want to make that into a decimal because I want a precise answer. And the square root of 49, I can see, is 7. So we just found sine to be square root of 40/7. And if we remember from a minute ago when we said sine has to be negative, we know that this whole thing right here should be negative. So there's sine. Alright. Tangent, we know, is equal to sine over cosine. That's using one of your identities, the quotient identities. Okay, and we have some values now that we can start subbing in, right? We've got sine, which is negative square root of 40 over 7, and cosine, which is negative 3 over 7. And I'm dividing a fraction by a fraction, so I'm just going to multiply by this reciprocal. So let's see, that should be 7 over 3. Well, my 7s are going to cancel out. These negatives make each other positive, and we've got tan, we've got square root of 40 on top, and 3 on bottom. So tan is the square root of 40 over 3. Plus, it's positive, which is something that we were hoping for. Alright, now you got the other three trig functions, ones that we're not so used to working with most of the time, right? Secant, cosecant, and cotangent. Well, we know the reciprocal identities working with sine, cosine, and tangent that we can get those other three, right? We know sine is going to be equal to 1 over cosecant, right? Those are the reciprocals. So if I just substitute, let's see, if I solve rather for cosecant, which is kind of going to be the reciprocal of this, right? Sorry, that was kind of confusing the way that I'm saying this, but cosecant is 1 over sine, right? That's also one of the reciprocal function identities. We know a value for sine that we can substitute in, right? We have it over here. We found it to be the square root of 40 over negative 7. Okay, if we're dividing 1 by that whole thing, this is just going to end up becoming the reciprocal, right? We've got negative 7 over the square root of 40. Now that's okay, except that we don't want to have the square root of 40 on bottom, so we're going to have to rationalize. Leaving us with cosecant equal to negative 7 root 40 over 40. Okay, secant is going to work pretty much the same way, right? We know secant is equal to 1 over cosine. Cosine is negative 3 over 7. Again, if we divide 1 by that, we're just going to take the reciprocal, right? Negative 7 over 3. And we don't have to worry about any kind of rationalizing there, right? So that's secant. And then you got cotangent. Cotangent is equal to 1 over tan. So we found tan already. Again, we're dividing by 1 by this, so just take the reciprocal, 3 over square root of 40, and we rationalize, giving us, we'll say cotangent equal to 3 root 40. That's going to be 40 squared, so that'll cancel out, right? The square root and the square, giving us cotangent 3 root 40 over 40. Okay, that was probably a lot. You might need to end up going back and watching some of this stuff over again before you try this one on your own. But if you want to go for it, pause the video and check it out when you're done. Alright, so let's check out how this one worked. Maybe you were struggling, or maybe you got it right away. I don't know. But they give us cosecant. It's positive, and it's 5 over 3. We can get cosine pretty quickly. Oh, they also give us tan's positive, and we'll deal with that in a minute. Cosine, we know, is equal to 1 over, oops, I'm sorry, I'm doing the wrong thing here. Sine, rather, is equal to 1 over cosecant, which they give us. Right, so we can find sine by just taking the reciprocal. That's what's going to end up coming in here, 5 over 3. Take the reciprocal, and you get 3 over 5. Now, this is something interesting because we can see that sine is positive and tangent is positive, and we needed to know that information to figure out the quadrant that we're in. And that happens sine positive, tangent positive in quadrant 1, which also gives us cosine positive. So this is a good thing. Every value that we get, it should be positive, right? Sine, cosine, tangent, and then all the reciprocals. So we got sine pretty quickly. What's some other ones that we can find? How about cosine? If we do the Pythagorean identity. Sine squared, we said was 3 over 5 squared. Alright, just squaring. We'll get rid of this from both sides by subtracting it. Let's see, 25 minus 9 on top would be a 16. 25 on the bottom. Take the root of both sides. And we're coming up with 4 over 5 for cosine. Alright. Let's see. Sine, cosine, tangent. Tangent equals sine over cosine. I have some values that we can just start plugging in here. 3 over 5 divided by 4 over 5. I'm going to multiply by the reciprocal. Let's see, these 5's cancel out, and that leaves us with tan equaling 3 over 4. Alright, next we come secant. Secant is the reciprocal function of cosine, so we're just going to take the reciprocal. Right? Secant equals 5 over 4. And cotangent is the reciprocal of tangent, so we're just going to take the flip of that. And there you have it. I kind of went quick on those last two just to save some time on the video. Alright. Those problems weren't actual identities as you would see them in textbooks or what a professor might call them or a teacher might call them. Right? Those were more just solving using some identities. But what we're seeing right here in front of us is an actual genuine identity. We're trying to simplify something big and making it as simple as we can get it and showing its true form, its true identity. I don't think that's why they call it that, but maybe someone out there knows and can leave it in the comments why they call them identities. I don't know. Anyways, we're definitely going to want to keep these handy. So if you have this printed out or from your notes, keep them handy. Okay. First of all, I'm looking at this whole thing, and it's filled with different trig functions. I want to try to get it to sine and cosine. That's what I like to work with. Or just sine, or just cosine, whatever. But I'm going to try to boil it down to those as much as possible. Right? And right here, right off the bat, I see Pythagorean identity. Right? This whole thing is equal to sine squared. And we still have this cosecant squared to deal with. Now, again, I want to make everything into sines and cosines. Something that I notice is that cosecant is a reciprocal of sine. So I have sine squared times 1 over sine squared. And I'm just going to put sine over here over 1. They're multiplying, so if I multiply, sine on top times 1 is sine squared. 1 times sine squared on bottom. And what I should notice here is that I have the same thing over itself and that just gives us 1. So this whole thing was really just a 1. Okay? Try this one out. Pause the video, use your trig functions and identities rather, and work with that one. Alright. Hopefully you weren't waiting for me to say to pause the video. You just did. Alright. Let's change secant into cosine, right? Because that's the reciprocal. So that's going to become 1 over cosine. Then this whole thing in here, 1 minus sine squared, that's really cosine squared. Just the Pythagorean identity here. Okay? Square and square root, those things eliminate each other. And what we have is 1 over cosine. We're left with just cosine, which is really cosine over 1. And now we've got that multiplication thing happening here. Cosine over cosine. Same thing divided by the same thing. It's going to be equal to 1. Okay, not too bad. Hopefully you were able to do that one. It was a pretty simple starter. Now we're going to step it up just a little bit. But the game plan is still the same. We're going to try to turn everything into sines and cosines. So let's start with tan, because these are already sines and cosines, but tan, we know, is sine over cosine. And we're multiplying by sine, so we'll put sine over 1 plus cosine. Alright. Well, multiplication tells me that this is sine squared over cosine. And I'm going to put cosine over 1. Now, in order for me to add these together, I need a cosine on bottom. And lucky enough, I can just do cosine over cosine, which is equal to 1. So I'm not changing anything here, right? Cosine over cosine we set up here was 1. Well, that's fine. I can multiply by 1 and not change anything. So if I do, I get sine squared over cosine from up here. And now over here, I have cosine squared over cosine. Now I can add those together. Sine squared plus cosine squared all over cosine. That should go off my head as the Pythagorean identity as equal to 1. And we're still over cosine. This is a reciprocal, right? It's literally the reciprocal of cosine. Which function is the reciprocal of cosine? Secant. Okay, so game plan for this one on your own. Try to change things into sines and cosines. Pause the video, try this one out. Alright, let's check it out. We want to change cotangent and tangent into sines and cosines. So quotient identity says cosine over sine for cotangent, sine over cosine for tangent. I can't add these while they still have different bases. So what I'm going to have to do is make them both have one of these. Right? If I multiply by sine over sine, and I multiply over here by cosine over cosine, these are both 1. So that's fine. And I now have cosine sine on the bottom. So I will be able to add in a moment. Right? Cosine squared on top, sine squared on top, and now I have cosine times sine on bottom. Cosine, sine. Alright, this is a Pythagorean identity. So we got 1 over cosine sine. Maybe you got to here and kind of got stumped a little bit. Maybe you figured it out. we're going to break this up into 1 over cosine times 1 over sine. That's okay. That's just regular multiplication of fractions, right? 1 times 1, so that's fine. What I'm noticing is that each of these are reciprocals of cosine, which we know is secant, and sine, which we know is cosecant. So your answer is secant, cosecant. That was a tricky one. Maybe you got it. Maybe now you see where you made your error. Right? But no matter what with these, you got to try them out and don't quit on them because they take practice. They really do. Okay, we've only got this last page to go through. We're going to be doing a little bit of factoring here. Okay, we're still simplifying, but what we might notice is that we have something that can be pulled out from both of these, and it might do us some good, right? I have secant and secant, so if I pull out secant from both, that leaves me with sine squared minus, let's see, secant, if I pull, I only get 1 left in there. And that was a smart idea because we know sine squared minus 1, that's Pythagorean identity, that's really cosine squared. Right? So we're in pretty good shape right now. Oh, almost. I was actually wrong about that. I skipped something kind of important. This should be 1 minus sine squared, right? That's a problem. So the only way for that to become 1 minus sine squared is we're going to have to multiply by -1. Oops. Alright, so if I do that, we distribute to these terms, and we end up getting negative secant times 1 minus sine squared. Alright, sorry about that. I totally forgot that wasn't quite what we needed yet. But we're still in good shape, because now we know that we can get cosine squared. And here we know secant is a reciprocal of cosine, so we get negative 1 over cosine. Okay, so we're actually in pretty good shape, because we're multiplying here, right? This is what's been happening all along, and we have cosine squared over 1, and I can start to see that I can get rid of some stuff. All right, and what we have left is -1 times cosine, which is just plain old negative cosine. All right, so that one was not really bad once you factored out and then got it into the right form. So try this one out and resume play when you finish and you want to check your solution. All right, let's see how this one came out. I'm noticing I've got cosines that I can pull out from both. That leaves us with 1 plus tangent squared. That is fine. That's actually a Pythagorean identity. We don't have to do anything to it, right? It's just cosine times secant squared now, right? Pythagorean identity. This is good news too, right? Secant is a reciprocal of cosine. So what we have is cosine times 1 over cosine squared. That's not floating for no reason. I'm going to put it over 1. And I can already see that we can get rid of a cosine here and a square. Alright, so we've got 1 over cosine. Well, what's 1 over cosine? Secant. Pretty easy. Alright. Same idea. We're going to be factoring, but this time it looks kind of more like a quadratic. In fact, it is a quadratic, right? We have secant squared and secant, and then we have a constant. So why don't we just treat this like something that we've worked with before. And we'll just substitute x in. Now, you don't technically have to do this, but I think it's easier to work with if it's written out with x's, right? Because now I can see that I need to factor this, right? I know I'm going to have to, I have to have 2x and an x here. There's no choice, right? And I want to think about, all right, I need to multiply to get -4, and I need it to be large enough to become -7. So if I were to do 2 times -4, that's -8. In order to make this just plain old 4, that would have to be 1 here, right? That gives me the -4, and then we said -8 plus 1, that gives us a -7. So factoring is a lot easier once we have it in this x form, and all I have to do now is substitute secant back in for x. So we get 2 secant plus 1 times secant minus 4. There you go. So really, the trick here is you just change the x's and it makes it a little bit easier. This one, they give us x squared minus 1 if we just get rid of that sign for a moment. And we should notice this as a difference of squares. So we've got x minus 1 and x plus 1. And I'm just going to put sine back in for both. So you got sine minus 1 and sine plus 1. Try this one with cotangents. Pause the video and resume when you're ready to check. Alright. So we got 3x squared plus 16x plus 5. Alright, well, when we factor this, I have to have a 3x here and I have to have an x here. And then 5. 5 is prime. So I know I can only break it up into 5 and 1, right? But I want this thing to become 16. So the 3 and the 5 are going to have to multiply. And by the way, I know that they're going to be positive, right? Because this is positive in the center. So these both have to be positive. So there's the factor. And then we just got to substitute cotangent in for x. 3 cotangent plus 1 and cotangent plus 5. Alright. That's it for that lesson. Kept it under 30 minutes this time. You're welcome. If you have questions, leave them in the comments, or better would be to bring them with you to class. These are not easy. I hope that you didn't struggle through this, but if you did, then you're not alone, because this is not the easiest thing to get the first time. So I'll see you next time when we're going to do some more identity stuff. Bye.